Hi, today I'm going to talk about basically high-pass filters for RF applications. Of course, high-pass filters are used in audio, video, and so on, in many different sort of applications. But nonetheless, today we're talking about the RF high-pass filters. Okay, a high-pass filter, if you look at it over there, basically has got a center frequency which everything below the center frequency is actually attenuated, and after the center frequency everything, all the signals are passed through with a very slight attenuation because of the losses of the plugs and components and things like that, but negligible. Okay, so the moral of the story is everything below the center of the high pass or cutoff for the high pass filter below is actually attenuated. Now, you do get the second order, first order, second order, third order, fourth order, up to 10th orders sort of filters, which become more impractical more than 10th order type of thing. But nonetheless, okay, so this is basically one typical, basically designed in filter software, assimilated it in Spice, and gave me very good results. And I used a sixth order filter. Now, the reason why I use the sixth order filter, and the reason why it's called sixth order, because if you count it, you can actually see 1, 2, 3, 4, 5, 6. 6 components, and that's why it's called the sixth order. Okay, so what I've done is I calculated, I measured, and I designed the inductors and the closest, and I corrected because according to the capacitors that I had available. So basically, if you look at it over here, this is the basic design of the sixth order filter. And if you look at it, let me just bring the camera a bit closer, you can actually see it, and it corresponds over here. I'll just go component by component. You can see this particular capacitor, which is that one over there. There is the inductor. There is this inductor here. Here is the inductor over there. The capacitor over there, which is that one in the middle. Then you got the inductor over here, which is that inductor over there. Okay, and then of course you get the third capacitor, which is that one over there, and then you got the third inductor, which is this one over here, this big one. Okay, now what I have done is I have added, according to customers, we can make whatever plugs, SMA, BNC, RF plugs, RCA plugs, F connectors and so on, the material. So I basically added male, because this particular filter, it's that I've designed, it's with a cutoff frequency of 75 megahertz. And the reason why I used what you call it a sixth order filter is because of the actual attenuation that I would like to obtain. A sixth order filter basically gives me approximately about 36 dB, because it's approximately 6 dB per octave. So if it's a sixth order filter times 6 dB per octave, that approximately will give me somewhere up to 30 something dB attenuation. Below at around, because it's designed for 75 megahertz, half of it, it would be 35, and that would be 1 octave lower, below 75. And at that particular point, it will give me approximately, about 30, anything up to 36. Of course, there will be losses and so on. So more realistically, in a region of 30 dB actual attenuation. And what I've done is, as I said, I've used the different, like with BNCs different plugs, or even the coaxial cables, or it can be soldered direct onto whatever circuitry that you want to attenuate everything below 75 Hertz. Typical application, I used it for filtering all the noises from switch mode, power supply, solar, PCs, and so on, for FM radios, for FM band, anywhere between from 88 megahertz up, type of thing. It can be used also in the airband radios, which is up to 130 something megahertz, and so on. So it's a very, very, very good filter that I've actually designed, and it gives me a decent attenuation, which is about 32 dB, and that 32 dB attenuation would give me approximately 1200 plus minus 1200 times attenuation of the unwanted signals below 75, which is it's fairly decent filter. So anyway, let's start from scratch. I'm going to demo, and I'm going to take this sort of filter, and of course, again, I'm going to use my portable for a quick demo generator, and I'm going to just plug in the filter, input into the filter, and then of course, let me just get my camera, okay, and I'm going to plug it in direct into the spectrum analyzer and see what type of results we're actually getting. Okay, so if you look at it, I'm just going to expand, all right, there we go, okay, so right now, if you look at it, okay, my minus 3 dB, okay, it's right on 75 megahertz. So at that particular point, I'm getting about 29,2, okay, and just above, because I don't want to attenuate the FM band, okay, FM band starts from 88 megahertz. So just above 3 dB over here, I'm getting 32 dB. Yet over here, minus 3, that's about 29 if you look at it. So right over here, it's actually minus 29,2. But if I shift this particular mark a little bit here, right but on top, it will give me 32 dB. And I'm just going to do that. If you look at it, okay, let me just put this, sorry, let me just get my bearings here. There we go. It's exactly 32 dB attenuation. So at 75, which is my minus 3 dB, let's just do it. Okay, let me just put it there. All right. At minus, okay, which is about 29, whatever, 2. Okay. So I'm about 3 dB minus, and that's my sort of. So if I look at it from minus 75, at 35 basically is somewhere over there. So if I measure the signal right over there with the cursor, I will get about attenuation of about 32 dB, which is at 35 megahertz, which is 1 octave. Octave is basically a ratio of 2 to 1. So it's either up or it's either down. It's either doubling or halving the actual frequency. So 1 octave lower than 75 is about 35 megahertz, and 35 megahertz is right here. And if I actually measure it, I actually measure and I get about 32 dB attenuation, which corresponds with a sixth order filter, which gives you about 35-36 dB attenuation per octave. So, as I said, I can even zoom even more and go and split the hairs, but this is just for a quick sort of explanation. So, just by using this filter that I'm actually measuring, by plugging it into the two-way radio, let me just say, for example, okay, now you get, of course, FM radios on this, if I plug it in here, now I have eliminated all the noises, and only pure FM is actually getting picked up from an antenna and things like that. So it's plug and play. And depends what kind of a socket you have on your hi-fis, on your portable radios, on wherever you want to apply the filter. It's not a problem for us to actually change it and to, So, in actual fact, let me plug it in one more time. And basically, that's what a high-pass filter is all about. That's what basically what this device does. It attenuates everything below. And all the switch power supplies, they work anywhere up to from like 20 kilohertz to about 48 kilohertz type of thing. And they generate a lot of noise, which actually gets picked up with the FM antennas and does a terrible interference to the actual hi-fi systems and things like that. Where with this filter, plug and play, it's not an issue any longer. So, as I said, on that note, basically, we can make it into any order, the filter. Just, I'm going to make these type of filters, FC75 high pass minus 32 dB. The reason why, because it gives me a 32 dB attenuation, which is about 1200 times attenuating all the signals from 75 to whatever 0, which is quite a decent sort of attenuation. And on that note, basically I summarize the high-pass filter, and you can actually see it over here, the schematics again one more time. That's the generator, that's my spectrum analyzer, which is 50 ohm, this is the components that I have basically designed, and I actually made the coils precisely, and of course trimmed them by plug and play and measurements or whatever, so I can get a very high accuracy with the cutoff point at 75 megahertz. Let me just put it over there at 75 megahertz. So it's precisely there. And if you look at it, it's precise. As I said, I can zoom into it, but I don't know how clear you can actually see it right now. But it's very, 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 very accurate. Yeah, type of thing. So on that note, on the high-pass filters, that's basically a very quick demo of Batos HiPass RF filters. And I hope it will help somebody, to understand what the filter is all about. And the question probably that you have got in the back of your mind is, do they really work? Of course they do. And that's why the filters are irreplaceable. And they have to be used probably in another 1,000 years. Because there's nothing else that will attenuate electric signals besides the filters. Yeah, on that note, thank you very much. Till the next time. Ciao.